So today we're going to learn about frictional forces. And this type of friction is not air resistance or some of the other types of resistance forces we've looked at. This type of friction acts between two solid surfaces that are in contact with one another.
So when two surfaces rub together, we get that frictional force. You can see that in this puck as it's shot across the table. It's rubbing on the table surface, and friction opposes the motion, slowing that down. This is actually an air hockey table, so when we turn the air on with this table, it creates a cushion of air below the puck. And so rather than dragging along the tabletop, creating that friction, the puck then glides along this air pocket and creates much less friction. You can see that the puck is moving fairly freely.
So we have two types of this type of friction. Or two categories of friction. One is static friction and the other one is kinetic friction. Static friction acts between two surfaces that are stationary. So if you tried to push on your table right now and you didn't give it a very big force, it wouldn't move. And if it doesn't move, that means that the forces are balanced on it. And so you're pushing forward on the table. It must be some friction that's pushing back to stop the object from moving forward. And that's static friction that's pushing back on you. Rolling objects also move forward because of static friction. When the tire is touching the road, it's stationary to the road. And so it's static friction that moves your car forward, pushes your car forward, which is why you had some issues this week or last week with the snow. And there was a lack of friction. It caused your car to slide often. Static friction is a somewhat complex force because it's not a constant force. If you push a little harder on your table, static friction pushes back a little bit harder, keeping your table from moving forward. Eventually, if you push hard enough on your table, you can break through static friction and your table will begin to slide. Kinetic friction is that second category of frictional force, and kinetic friction is sliding friction, and it always acts in the opposite direction of the motion. Kinetic friction is a little bit more straightforward. It's a constant amount of force. So we have an equation to calculate these forces, both the kinetic friction and the static friction. I call it the fun equation. Here it is. We say the force of friction, F sub F, is equal to the coefficient of friction. This is a Greek symbol. It's called mu, times the normal force. So F-U-N. It's our fun equation. This coefficient of friction is a constant for any two surfaces that are interacting with one another. It's a unitless value, and it's always less than 1, so it's a pretty small value. If you think about why it's unitless, because that's somewhat confusing, force of friction has a unit of newtons, normal force has a unit of newtons, and so coefficient, a newton is equal to a newton. This coefficient can't have a unit. Also, if you look at this equation, there's two factors that affect the amount of friction between two surfaces. How rough the surfaces are, which is what the coefficient measures, and how heavy the surface on top is, which creates the normal force. Because we have these two types of friction, static and kinetic, the equation, the fun equation, doesn't change for each of these values of friction. What changes is the coefficient, the constant. So if we're trying to calculate the static force of friction, we would use mu sub s, the coefficient of static friction. And if we're trying to calculate the force of kinetic friction, we would use mu sub k. Static friction is always a greater force. So static friction always exceeds kinetic friction, which means the coefficient of static friction always is larger than the coefficient of kinetic friction. So one use in your life is anti-lock brakes. Because static friction is a greater force than kinetic friction, you would much rather use static friction with your brakes to slow your car to a stop. And so anti-lock brakes help to use static friction in your braking process rather than that sliding friction of kinetic friction.
Okay, so now let's look at this example question with a friction problem. So it says a block of 20 kilograms of mass is pushed horizontally with 72 newtons of force. So we've got some block here and it's being pushed forward. We'll just say this is my force of push with 72 newtons of push force. And what else are they telling us? They're telling us that the mass of this block is 20 kilograms. So mass is a variable that is a force variable, but it's not an actual force. And so how do I translate that into my free body diagram? I would say the block has weight, force of gravity, and mass is directly related to that weight. And then we know that the box is not falling through the ground, so we have a normal force, the force of the ground, applying a force up. And they're telling us that we have a coefficient of static friction and a coefficient of kinetic friction. Because of that, we know that there is also friction. Now, I don't know how much friction there is, so I'm going to use a bit of a dotted line because I don't know if the forces horizontally are balanced or unbalanced. They're not giving me enough information yet just in this reading. And I also can write my Newton's second law equations. So the net force vertically in the y direction would be the normal force minus the force of gravity, so all the forces up minus all the forces down. That's equal to the mass times the acceleration in the y. And my net force in the x direction would be everything to the right, which is my push force, minus everything to the left, friction. And that's equal to mass times the acceleration in the x. And it's a question right now. Do I have an acceleration in the x? I don't know. But I do know that there is no acceleration in the y direction, so the forces in the y direction are balanced. Okay, so those are my givens, including my free body diagram. Let's go to the actual problem now. Part A, will the block move from rest? So it's at rest. We want to get it to start sliding. To move an object, to make it slide, we have to overcome static friction. So really, this question is sort of code for, is the push force great enough to break through the force of static friction? So I need to figure out what the maximum static friction is, and then I can compare that to my push force and figure out from there whether it will begin to slide. So here's my fun equation, my force of friction, and I'm choosing static, so I'm using my static coefficient here. I need to calculate my normal force. Got an equation up here already. We know that the normal force has to balance out the weight for there to be zero acceleration vertically. So to calculate the normal force, I'm going to need to know my force of gravity, and that's mass times the acceleration of gravity. So 20 kilograms times the acceleration of gravity, 10 meters per second squared. That would be 200 newtons. So if the weight is 200 newtons, the normal force also needs to be 200 newtons because the net force in the y is 0. So now I have enough to calculate my force of static friction. My coefficient of static friction is 0.5 times my normal force, 200 newtons. So I'm going to get 100 newtons as my answer. Now, this is not the answer to the question. The question again says, will the block move from rest? So my force of static friction maximum is greater than my force of push. So is the force of push enough to break through the force of static friction? No, it's not. If part B said how much force is required to get this block to move, I would need to apply 100 newtons of push force. And then we know that it would be just a little bit more, but about 100 newtons of push force would get this block to move. So no, the block will not start sliding. And then part B. Part B says, if the block is already sliding, find the acceleration. So they are asking me for this acceleration in the x direction, and I've already gone ahead and written that equation. So let me just solve for acceleration in the x using my Newton's second law equation. That would be the push force minus the force of friction divided by the mass. So let's look at these numbers. Force of push, I know it was given to me, 72 newtons. Mass was also provided for me, 20 kilograms. Force of friction. This block now is already sliding. So if it's already sliding, what kind of friction is opposing the motion? So it should be kinetic friction that we need to find. And I have found the force of static friction. I have not calculated the force of kinetic friction. So the first thing I'm going to do is calculate that force of kinetic friction. I'm using my fun equation again. I'm just going to use the kinetic coefficient instead of the static this time. I know all of these numbers, so it's 0.3 for the coefficient, unitless. And then the normal force, I already calculated that, 200 newtons, so I can substitute that in. And so this would be 60 newtons of frictional force. So now solving for my acceleration, the push force is 72 newtons minus the force of kinetic friction, 60 newtons, divided by the mass, 20 kilograms. And so that's 12 on top divided by 20. So the acceleration in the x direction is 0.6 meters per second squared. So this question looks a lot like our other Newton's second law questions with free body diagrams. We just added one more step. Instead of talking about this generic frictional force, resistance force, we now have this equation that we can use to calculate that frictional force. So we've just added one more step, one more piece of information to what we already knew.